Good afternoon and welcome to the City Club of Cleveland. I'm Ben Bebenroth. I'm the chef owner of a restaurant on the west side called Spice Kitchen and Bar and a catering company called Spice of Life. I'm honored to be here today to introduce our speaker, Kristin Ohlson, author of The Soil Will Save Us, How Scientists, Farmers, and Foodies Are Healing the Soil to Save the Planet. I've made a few risky decisions in my career. Starting a catering business, providing local food and seasonal fare might have been one of them. Opening a restaurant was definitely another one. And my wife and I, Jackie, we recently leased land in the Cuyahoga Valley National Park. We have a 13-acre farm down there. But I've never felt more confident that this was the right decision than when I was reading Kristin Ohlson's book. I don't want to get too deep into why that's the case. I think by the time Kristin is through with her talk, you'll all understand. I'll just say one thing. The idea that those of us who care for a little bit of land have the power to contribute meaningfully and scientifically to halting climate change. This idea may change how you think about your own vegetable garden and your lawn and the parks that you visit. Let me tell you about Kristin. She lives in Portland, Oregon, and describes herself as a writer with one foot still in Cleveland, her hometown for 30 years. She has freelanced for the New York Times, the Christian Science Monitor, Salon, the Smithsonian, Discover, and a bunch of other publications, including the Cleveland Plain Dealer, of course. She has written on abandoned coal mines, entrepreneurs in Afghanistan, bioengineered zebrafish, and the science of art restoration. In addition to the book she is discussing today, she has also authored Stalking the Divine, a book about the Poor Clares of Perpetual Adoration, a convent here in Cleveland. Ladies and gentlemen, members and friends of the City Club of Cleveland, please join me in welcoming Kristin Ohlson.
Thank you. It's really great to be here. Coming back to Cleveland feels like, I lived here for 40 years. I just counted it up the other day. It was 40 years, almost day to day, from September of 1972 to September of 2012. So coming back here now, it kind of feels like I'm addressing a room full of my parents, like dozens of them. Before I spent the bulk of my adult life here in Cleveland, I lived in California at the edge of the very agricultural Sacramento Valley in the foothills of the Sierra Nevadas. And from my house, we could look out over the valley and see all this agricultural activity taking place out there, none of which interested me at all at the time. And my grandparents were farmers, and my parents were, my father was involved in state agriculture, and my parents were avid gardeners, and they were completely devoted to fresh produce, so they would go to every farm stand that, they knew where every single one was. But despite all of that, and despite the interest that I developed in gardening and in organic food when I got older, they had no idea about soil, and I had no understanding of soil. I didn't really start to think much about soil until a couple of years ago when I was talking to Parker Bosley. And he was telling me about the soil health movement. Now, as many of you know, Parker is one of those pioneering chefs who started to bring local foods into his restaurant back in the 80s. He had grown up on an Ohio farm, and he knew that the food he served was only as good as the land that produced it. So he told me I had written about him for Gourmet magazine, and he was just like one of the smartest people I had ever met. And so I was always getting back in touch with him, like, well, what should I be writing about now? What's interesting now? What's going on? So he told me that this soil health movement, also called carbon farming, also called sunshine farming, also called microbe farming, was the new thing that I should be paying attention to. And that means farming that actually builds up the carbon in the soil instead of depleting it. Farming that makes the land healthier. And so what I developed in the course of writing this book was this incredible sense of wonder about what's going on under our feet. I walk the earth really differently, knowing about the vastness of life down there. I was reading recently that scientists think there are 300 sextillion stars in the sky. So that's 3 followed by 23 zeros. So a lot of stars. But down in the soil, there's a comparable density of microorganisms, an incredible, according to some researchers, and there are different numbers, but an incredible 6 billion microorganisms per teaspoon of soil, which is impossible to imagine. It's one of those things that is just not possible for us to imagine. So we can't see them. And it's not just in the top couple of inches, although that's where the most active life is. They've been found as far as 10 miles down. When oil companies drill, they have to sort of be careful about contamination with these microorganisms who want to eat the oil. So we can't see them, but they're busily making a living down there, and everything that we want or depend upon up above the soil line depends upon them. So I want you to walk away with what I think is reasonable new hope about our environment. Working on this book and learning about the promise of soil allowed me to take heart, because I was really depressed about our environment before I started working on this book. I never doubted the global warming science for a minute. I didn't want to think about it. I kind of wanted to have up blinders saying, I agree, but stop bothering me. I don't want to think about it. Because it was so obvious to me that we as a people weren't doing the things that the climate scientists and the climate activists said we should be doing. We weren't dramatically diminishing the amount of carbon dioxide, of fossil fuel emissions. And I didn't realize it when I started working on this book, but early climate science projections didn't even take into account something huge, and that's the soil. And most of us don't take the soil into account. We think of Earth, planet Earth, as air and water and land, and we think of land as this like thin crust over this big dead rock hurtling through space. And even though I've been a gardener for a long time, and my parents were gardeners and my grandparents were farmers and all that, even though I have that soil, that connection to the soil that goes back generations, I didn't really understand when people would talk about life in the soil. When they'd say life in the soil, I used to think, yeah, moles, yeah, earthworms, yeah, beetles and ants. Okay. But those are like the leviathans of the soil. Those are like the great blue whales and the giant squids and, the great white sharks. It's what we don't see that makes the soil so alive. The tiniest life forms that have been there long before we and those other creatures evolved and we evolved, and they're crucial to the way the planet functions as one great ecosystem, and crucial to this lush green world that developed around us. So the recognition of soil microorganisms' importance is pretty new, and I think it's kind of like the recognition of the microbial community inside our own bodies. Our fear of germs, epitomized by those hand sanitizers in all the grocery stores, seems to me crazy when we understand that our bodies have 10 times as many bacterial cells as human cells. I think the latest count on the human microbiome is about 100 trillion. That's things living in us and on us. If you compare the human genes in our body and compare that to the number of microbial genes, it's really crazy numbers. 23,000 human genes to 3.3 million microbial genes. So we are pretty much a ship of microbes, one that's been designed and built by the microbes. And actually the correct word to describe us and most living things is supraorganism. We are an organism made up of many organisms. And if you took all those microbes out of our body, they'd fill up about a half-gallon jug and weigh a couple of pounds. Scientists now say that they're as important, that microbial component of us is as important as an organ, and that it's critical to our immune system and our metabolism and even to the way our brain works. And it's kind of, when I think about that, it's kind of amazing that doctors have been able to be helpful to us at all, up until like the last 10, 15 years when we started knowing this stuff. Because now doctors understand that we need to keep that microbial population vigorous, and we need to keep it in a certain balance. And it's, of course, not the case that all microbes are beneficial. Some are pathogens. But one of my favorite soil researchers says, well, most of them are really on our side. If they weren't, we would have been wiped out long ago. So just as people are starting to understand the importance of that microbial population in our body, we have to get to that point with soil. We need everyone from ordinary people and gardeners and kids to professionals and policymakers to understand that Earth's microbiome is even more dense and diverse and essential. And the only way we can live on this Earth without destroying it, and really the only way, is to learn how to live in harmony with that vast, invisible, but incredibly powerful biological force under our feet. So healthy soil has a vigorous population of microorganisms: bacteria, fungi, protozoa, microarthropods, nematodes, lots and lots and lots of tiny creatures. Scientists have known they were there for a while, but it's not until fairly recently that they have understood what they do in partnership with plants and why they're important to us. And that ancient partnership between, so we can't just think of the microorganisms themselves in isolation as being important. They are, but it's that partnership that they have with plants. And that's what created the world that humans, modern humans, evolved into, 276,000 years ago. Those microorganisms have been in the soil for around 2 billion years. When land plants arrived about 500 million years ago, they tapped into an already existing system for cycling nutrients and water around. So what are the terms of this partnership? Most of us already know about photosynthesis. This is the great biological marvel of our planet, which bacteria began 3 billion years ago in what's called the Great Oxidation Event, which changed the atmosphere into one that we could breathe and paved the way for us and other creatures. Photosynthesis is carried on by plants and bacteria. Both create oxygen. But when plants conduct photosynthesis, they perform another function that's really critical for keeping the world we inherited in balance. They use the energy from sunlight to pull, they have their solar collectors out there, and they're using that. They pull carbon dioxide out of the atmosphere, and they toss off the oxygen. That's their waste product. They don't need it. And convert that carbon dioxide into a carbon fuel, which they use for their growth. So they use it to, grow their stems and their stalks and their leaves and their flowers. That's what they need. That's their food. That's what they need to live. And when we eat plants, we are feasting on the carbon that they pulled out of the atmosphere. That's the carbon. But this is the really critical part. Plants don't use all of that carbon that they take, that carbon fuel. So up to 40% and sometimes more of that carbon fuel gets moved down to their roots, and it leaks out their roots. And when I first heard that, I just thought that was the craziest thing. Plants work so hard to do this, and then they get rid of almost half of it. So what they're doing is they are leaking that carbon fuel out through their roots, and in exchange, soil microorganisms are clustering around those roots. That's their food, too. So they're feeding those soil microorganisms in exchange for minerals that the soil microorganisms have liberated from rock and sand and silt and clay. So that's been the deal for millions of years. There's that exchange, carbon for minerals. So when you look at a plant poking out of the soil, don't think, oh, here's this one living thing sitting there in the soil. Around that plant's roots, down underneath there's like a Cleveland or a Paris or a Rio de Janeiro of active microscopic life, very, very busy. So that's how plants... partnership with soil microorganisms fertilizes plants. So there are some 98, I think, naturally occurring elements on Earth. It's possible that plants need every single one of them. That's what they get in that exchange. But this partnership is also the way that carbon builds up in the soil. So microorganisms eat that carbon fuel that they've received from the plants, and then they excrete it, and other microorganisms eat them and excrete it, and there's like this microbe eat microbe thing going on in the soil. That carbon fuel, which is also called exudates from the plant's roots, that keeps getting condensed and condensed and condensed in the soil. And another way it gets concentrated in the soil is that the soil microorganisms make a kind of a carbon glue. It's similar to the stuff on our teeth that we brush away when we get up in the morning. So they make a kind of carbon glue to build tiny structures in the soil to protect themselves and to regulate the flow of water and gases in the soil. So they engineer the soil. They're like tiny, tiny little micro-engineers. They engineer the soil and wind up creating what I like thinking of as like millions and millions of cups and saucers in the soil, just all these openings in the soil. Or another way to think about it, because I think we really have to come up with different ways of thinking about the world that we live in. Another way that I like to think about what it's like when we're walking over the ground is that we're not walking on solid ground. When we think of solid ground, it's being so heavy and dense, and it's like a coral reef. It's got all those pockets in it for air and for protection for the microscopic creatures and for gases. I mean, so think of soil as walking on a coral reef. Instead of solid earth, think of something that's kind of like a giant sponge. So good soil is full of that structure, and it's all held together by carbon. And this carbon-rich soil is dark. We instinctively know that dark soil is good soil. And I'm always kind of amused every spring when my neighbors, either here when I was in Cleveland or now in Portland, we start looking at our gardens and we think, oh, it needs a little something. And we go off to the garden store and we buy bags of mulch or compost. And a lot of those bags, you can see on the they've added dark coloring to make that stuff look the color that we know that soil should be. It makes us feel good because dark soil is good soil. But we don't think of it as that it's carbon in that soil that makes it good in good soil, and because we've gotten the idea that carbon is something that's bad, because we know we've overloaded our atmosphere with it, but we've gotten the idea that carbon is bad. I was talking to somebody about my book and all this stuff about carbon and how good healthy soil has lots of carbon in it. And she said, "Oh, poor soil." No, that carbon belongs there. It's a good thing. So good soil is also knitted together by microscopic mats of fungi which pierce the roots of plants and share water and nutrients within a plant community. And those hyphae, those long microscopic threads from the fungi, can run 250 feet or more. I met a researcher a couple of months ago who's studying forests in the Pacific Northwest, and she found that with that underground fungi network, she found that what happens in forests is that old trees are nurturing baby trees, trees that have sprouted there. Through that fungi network, they are circulating water and nutrients to those baby trees and helping them grow, even if they're in shadow. And fungi also create structure in the soil. They also make aggregates in the soil with those carbon-based glues, and they create channels in the soil that makes it really easy for water to move around. So it makes sense that healthy soil with all those cups and saucers and channels and coral reef is very porous. And because of that structure, healthy soil receives and holds water in a way that unhealthy soil can't, that sick soil can't. And that's really important these days because we're all worried about drought. We're all worried about either too much water or not enough water. Healthy soil handles both of those things. For every 1% increase in soil organic matter, which builds up through that partnership between plants and microorganisms, an acre of soil can hold an extra 25,000 gallons of water. So if rains don't come, the soil is still holding water from the last time it rained. And if 8 inches of rain fall in a few hours, the soil can absorb it and it doesn't run off into the streams. But the problem is that almost everything humans have done since agriculture began has disrupted that ancient partnership between plants and soil microorganisms. It's not just a problem with modern chemical agriculture, although that is the most effective way that we've ever come up with for ruining soil. But even way back then, as soon as we domesticated wild herds and changed the way they moved over the land, and as soon as we started to dig up the earth and plow, And as soon as we started to eliminate the great diversity of plants on the landscape and just grow that one plant that we wanted, that's called a monoculture. As soon as we started keeping the land bare around that one crop that we wanted, as soon as we disrupted the feeding relationship between plants and soil microorganisms with chemical fertilizers, we were disrupting that relationship. We started doing that like 10 to 12,000 years ago, agriculture. And when we started doing that, we started liberating millions of years of carbon that had built up in the soil and sending it off into the sky. Scientists estimate that we've lost 80 billion tons of carbon from the world's soils. So ancient humans warmed the climate so much from the way that they use the land, and that also includes burning down forests to create farmland, that one scientist thinks we averted another ice age 2,000 years ago. And today, land use related to agriculture itself accounts for 30% of the carbon going into the atmosphere. So all that carbon that's in the atmosphere is called the legacy load. And the climate change conversation that goes on in this country and around the world focuses on the 2 parts per million that humans keep adding to the atmosphere every year. And we talk on and on about reducing that. And of course, we should talk on and on about reducing that. But the conversation does not pay enough attention or the right kind of attention to drawing down that 400 parts per million. It's already there, that legacy load. If we manage to stop all fossil fuel emissions today, and we're not doing it, clearly, but if we managed magically to snap our fingers and stop all fossil fuel emissions today, that legacy load of CO2 that's in the atmosphere would continue warming the planet with disastrous results for at least another 30 years. And I heard a scientist the other day say hundreds of years, which was even more daunting. So we're totally cooked if we don't start removing some of that CO2 from the atmosphere. And the best way to do that, fortunately, we have a really good way to do that. The best way to do that, the cheapest and most widely available technology, the technology that's been at work for a very long time without glitches and without unintended consequences, is the technology that nature invented millions of years ago. Photosynthesis, which removes carbon dioxide from the air, and the partnership that plants carry on with microorganisms in the soil, which fixes that carbon underground. So how much carbon can be fixed in the soil? I had a phone conversation just a few days ago with Ratan Lal, who's an internationally respected soil scientist, who was the first person who was one of the first people to see this connection between degraded land and excess carbon dioxide in the atmosphere, and the first person to start talking about that and working on this problem. And when I first worked on my book, he was one of the first people that I went to talk to. And so he just told me a couple of days ago that the best research he's seen lately shows that using very simple agricultural techniques in common, in this case he was talking about no-till agriculture, where they're not opening up the ground with this big furrow, where they're trying to disturb the soil as little as possible, and a combination of that and cover crops. And cover crops are something that farmers plant to protect soil. It's not something that usually not something that they're taking to market, but it's just planted to protect soil. So that this newer research that he's seen that he thought was very promising said that we can draw down and sequester as much as a ton and a half of carbon per hectare, which is 2.5 acres. And I also know that there are other researchers out there who are a lot more optimistic, who think that estimate is too conservative. I know one guy's research in New Mexico shows that he's doing work, again, using very simple agricultural techniques that he thinks can sequester 10 tons of carbon per acre, using simple agricultural techniques. Our biggest impact on the environment is through agriculture. In our croplands, it's 4 billion acres around the world. In our pastures and rangelands, 14 billion acres around the world. Because of the kind of farming practiced by most agriculturalists, not people like this, not people at the people in the farmers market, but certainly the commodity producers of corn and soybeans and wheat and cotton and so on, the soil in most of our croplands and rangelands is really sick in a biological sense. And according to Ratan Lal, a quarter of the Earth's landmass is degraded and sick from human activity, from bad mining, bad farming, from mining, bad urban use, and so on. But we can look at that really shocking number that a quarter of the Earth's landmass is degraded and lacks carbon, and think of that as an opportunity. We know now that by using a combination of simple agricultural methods, we can heal the soil and draw down massive amounts of carbon dioxide from the atmosphere. So that degraded land that's been stripped of its carbon is a prime target. So is anyone doing this? I mean, is this all just a good idea? Is anybody doing this? Well, not enough people, but yeah, a growing number of people around the world. They're doing it not because, I mean, they're doing it for so many reasons. You know, there are some people that I interviewed for my book who were doing it not because of global warming. You know, they are, you know, some of them are in the camp that says that global warming, well, yeah, the climate might be getting warmer, but it has nothing to do with human activity. It's just a natural cycle. It's just a whatever. They're doing it. They're doing this soil health stuff because it makes their land more resilient, and it makes the food that they grow better, and it just makes sense to them in a lot of ways, including their bottom line. So that's the other thing that's really great about this movement. There's not really a downside. So the movement for soil health is all about mimicking nature in ways that enhance and protect that ancient partnership between plants and soil microorganisms. So when I started my book, I started by talking to scientists because I thought, well, that certainly must be where all the knowledge is. And a lot of them were really quick to say, you know, the science is not far enough along on this. The universities aren't doing enough. I mean, I later sort of understood why, which is that so much of the research dollars that flow to our land-grant universities are not, you know, it's not coming, the bulk of it isn't coming from the government anymore. It's coming from private industry. And, you know, private industry has a very big interest in the status quo. So the scientists that I was talking to said, you know, it's the farmers who are really doing the innovative work on this. So I was introduced to one of these really innovative farmers by a young guy working for the National Wildlife Federation. So this guy, the farmer who's the centerpiece of my book, is a guy named Gabe Brown, and he's in North Dakota. Just an awesome guy. And I see I'm like pushing up against the 1 o'clock mark, so I'll talk a little faster. He has a 5,000-acre farm outside Bismarck where he gets about 16 and a half inches of rain a year. So he began to change his farming in a really dramatic way about 15 years ago after he had this like biblical bout with nature where he lost his crop 4 years in a row. 1 year through hail, 1 year through drought, 1 year through late frost, whatever, 4 years in a row. So he really started to change the way he did his farming in a very dramatic way. And he had been educated in all the ways of conventional industrial agriculture. He had gone to ag school, so he had started off plowing, and with that there's like a very, very rigorous regimen of chemical application that goes with that kind of training. So he had been raised with all of that, and, you know, for all his cattle to have those fly-killing tags on their ears and all that. But after he had this terrible bout with nature, he had to change things because he couldn't afford the chemicals anymore. He was barely hanging on to the farm. So he started sending his cattle out to eat the ruined crops that were in the field. And he had gone no-till a little bit before his terrible bout with nature because it seemed to him that tilling made the land drier. So he had stopped doing that. Anyway, and he had started planting some cover crops. And he started noticing after a couple of years that his land was his soil was getting richer and darker and was performing better than his neighbors. So he's a really curious and bright guy, so he wanted to understand better what was happening on his land. So he started working with some area scientists trying to figure out what was going on with the soil. So he started to understand that his soil was becoming more resilient because he wasn't destroying all those that coral reef, those cups and saucers, and he realized that his cover crops that he was planting were keeping that underground, that it wasn't just that they were protecting the soil from getting blown away or getting rained away, but that they were pumping down nutrients to that underground community of soil microorganisms. So then he started to really go crazy with that concept. He has cover crops everywhere on his farm now, between the rows. If he gets a new field that's been farmed by somebody else conventionally, for a couple of years, he has cover crops, and then his cows eat it, and cover crops, and his cows eat it, trying to build up that community of soil microorganisms. He always talks about managing 2 herds on his property. The cattle, which he uses to mow down the fields that are after he's finished harvesting them, but the herd of microorganisms under the ground, and he talks about that herd underneath the ground as being the most important herd, his most important herd. That's the one that he really has to keep his mind on. So the reason I really like to talk about Gabe Brown and his work is that I think that we are often told that we have a choice about the kind of farming, about the way that we raise our food, that we can either do it right in a way that respects the landscape and respects nature, or we can do it in a way that makes a lot of food. And that those are our choices, and I've heard it from so many people, oh yes, organic farming, all this kind of farming that you're talking about would really be good, but we have 9 billion people that we have to feed, and so we just have to put on more chemicals. And it's just, one of the things that I love about the story of Gabe Brown is that he is showing that that's not true. Like for instance with corn, he raises 27 more bushels of corn per acre than the county average where he is. But he spends less than half of the amount to raise those bushels of corn that his neighbors do because he's not buying all those chemicals. And another thing that's really important in this time of drought is that when he first took over that land, farmers get a test done on their soil. It's called a percolation test, or water infiltration. It's like how much water will percolate down in the soil in an hour. So when he started on this land, he got a half an inch of water would percolate in an hour, and that was it. That was how compacted and ruined the land was. And he went from that to 8 inches. So it's, he doesn't even worry about drought anymore. He's got this vast reservoir of water that's held in his soil. So he's an example of somebody working with this partnership between plants and soil microorganisms and thriving as a business person because of it. And there are thousands of farmers doing this, and hundreds and hundreds of farmers go visit his land every year. And he was just featured in an article in the New York Times, where people are just blown away that somebody can farm this way and be very successful, but it in fact is happening. So I think this is a really hopeful and exciting time. I mean, agriculture is the biggest way that we have an impact on our world, and if we can change the way we do our agriculture, we can change our world a lot. So let me just end with a quote from Peter Donovan, who's in my book, and he's mounted something called the Soil Carbon Challenge. He travels all over the country measuring the carbon content of soil on farms and ranches, and people buy into this contest. And whoever raises their soil carbon the most gets a prize. So I told him when I was meeting with him, I told him how amazed I was that everyone in this soil health movement that I talked to was so optimistic, and everybody else I knew was so depressed about the planet's future, about what's going on in our world. And I asked him why he thought that was, and it seemed like it was just beyond in having a good job. And he said, and it still gives me kind of chills every time I read it, he said they were optimistic because they're connected with the most powerful geologic force, which is life. Most of what we take to be the physical environment is the creation of living organisms over time. That is a different paradigm than the idea that life is a fragile passenger on a dead planet. So we're not a fragile passenger on a dead planet. We have powerful allies in the soil, and we're understanding more and more about what they do and how our actions can help them or hurt them all the time. And we can all play a role in helping them by the food that we choose to eat, by the way we treat our land, and by the kind of choices we tell our government to make. Not that it's a slam dunk, as you know, there are very powerful vested interests in conventional industrial agriculture and in the food system in general who stand to lose a lot of money if we change the way that we do agriculture, and even if we change the way we take care of our lawns. But we have allies. I like to think of all those life forms in the soil as heroes of the underground, and I like to think that all of us can be heroes of the underground too by working with them. So thank you.
Really nice. Great job. I'm going to do the little thing. Have a seat for a second. It's really interesting to hear that phrase, heroes of the underground, used literally, not as a metaphor. I'm Dan Moulthrop, Chief Executive here at the City Club, and today we're enjoying a Friday Forum featuring Kristin Ohlson, author of The Soil Will Save Us, How Scientists, Farmers, and Foodies Are Healing the Soil to Save the Planet. We encourage you to organize your questions for our speaker now and remind you that your questions should be brief and to the point, and everyone is invited to ask questions, although we may only have time for some. We welcome all of you here and those joining us via our primary media partner. That's 90.3 WCPN, WVIZ PBS, 104.9 WCLV IdeaStream, or one of the many other radio stations across the country and across the region that carry City Club programs. Radio and television broadcasts of the City Club are made possible by Cleveland State University and PNC. Our live webcast is supported by the University of Akron. Be sure to join us next Friday, June 26th, as we welcome Dr. Kirsten Ellenbogen, president of the Great Lakes Science Center, for a conversation on how to transform our future workforce. And it's not just about STEM education. That's part of it, but honestly, we were talking about it. It's not just about STEM education. You want to be here for sure. Okay, moving along. For more information about that forum or any of our upcoming or past forums, please visit us online at cityclub.org. Our sponsor for today's program is a single entity, formerly known as two entities, the Cleveland Botanical Garden and the Holden Arboretum growing together. We thank you both of you and your both campuses and your single organization very much for your support. Additionally, we welcome guests at tables hosted by the Cleveland Council on World Affairs, the Garden Club of Cleveland, the Ohio State University College of Food, Agricultural, and Environmental Services. We thank all of you for your support. Now it's time to return to Kristin Ohlson for our traditional City Club Q&A. As I said, we welcome questions from everyone, including guests. Holding our microphones today are our marketing and outreach specialist, Kirsten Pianka, and City Club intern, Wesley Allen. First question.
Hi, Kristen. Thank you so much for your expertise and your time. Interestingly enough, my thesis advisor's office was right next door to Ratan Lal, so I got to talk to him a little bit. He's a cool person. Another person at Ohio State University who came to mind, and this is where my question comes from, is I can't remember his name, but he worked in food security and agriculture, and he worked in Sokoine University in Tanzania, and his argument about organic farming and means of organic farming, as far as to your point of it actually producing more food for a strained population that's looking to feed 9 billion people. He said that it might work in North Dakota, but it perhaps wouldn't work in Tanzania, where it's arid and there's lots of desert, and that's the place where food shortage is seen most. So could you speak to that? What you would say, perhaps in response to someone like him who's working in areas like that throughout the world?
I think in every area throughout the world, if you don't have good soil, you're not going to be able to grow food very well. So I think that's always going to be the first thing that people need to address is what kind of shape is the soil in. And people, no matter what the climate is, people can make their soil better. I'm not sure that people. I think in some places there is going to have to be somewhat of a transition from the kind of agriculture the kind of chemically intensive agriculture that they practice now over to a more natural system. But I do believe it can be done. I think the numbers are usually that it takes 3 to 5 years to make that transition. And farmers, I think when it works best, farmers are being encouraged in some other way, financially, monetarily, to make that transition. But then after they do, that other system should be working for them. I mean, I think that in most of the places now that are having such a terrible time farming and with their land, it's the land has been really degraded by the kind of agriculture that we've practiced since the Green Revolution. Yeah.
Kristen, this information about the soil underground is absolutely fascinating, and I appreciate your view about how soil helps feed the masses. So my question feels a little frivolous as I think about my gardening and my lawn and my flower bed, and there's a few vegetables. But what are the simple strategies, the simple agricultural strategies that I can use to heal my land?
Yeah, no, I love the idea that we all in our own little space can do what we can. When I'm working in my garden, I'm always like thinking, what would Gabe Brown do? So I'm always trying to disturb the soil as little as possible. So I remember when I first started off gardening, I would get out there with a shovel and with a shovel and a pickaxe in Cleveland Heights and be digging for hours and hours. The prevailing wisdom at that point was that you had to dig down 2 feet and dump it over, and I don't do any of that anymore. I disturb the soil as little as possible. So if I have something to put in, I make a space that's just big enough for that thing and put it in there. I mulch heavily. So I disturb the soil as little as possible. I mulch heavily. I mean, I think that what I have taken away from the farmers that I've talked to is that there should never be bare soil. Never bare soil. It should either have something growing on it, have roots in it, or else dead plant material there, so that those soil microorganisms are always getting fed, either with that dead stuff or with new, fresh plant root exudates. So I always have the stuff covered, and I try also to have a great diversity of plants growing everywhere, because that's another lesson from some of these farmers who are really changing things and changing for soil. So like Gabe Brown, where he's farming, he has native prairie that's not too far away. Well, a botanist went out there and counted up all the plants that were growing in a square foot of that native prairie and counted 140 species. So he's trying, nature is very diverse. Nature has lots and lots and lots of different things going on. So he tries to match that by having cover crops growing among his crops on other fields that have 25, 30 different species. So I don't pay as much attention to my garden as I should, and certainly not as much as a farmer would whose livelihood depends on it, but I try to get a great diversity of things growing in there. I'm just, somebody sent me a book to read, and writers like to get blurbs on the back of their book, so it encourages people to read. So somebody asked me to blurb their book, and he's a soil scientist and his wife is a biologist, and they were talking about starting off putting in a new garden in Seattle where the soil was just terrible, and it was really great to read about them. They're bringing in organic, plant material from all over. They're going to the coffee shops and bringing back pounds, huge bags of old grounds, and they're going to tree cutting services and bringing back huge bags of wood chips. And they took this lot that had terrible soil to one that had beautiful soil in a couple of years by layers and layers of all these different materials for those soil microorganisms, for those microorganisms to start to chew on and transform.
So your assertion about, and I agree with it, that the carbon concentration in the soil is dependent on the vegetation present. What is your plan of attack, or the scientists that you've talked to, your plan of attack for areas like with Tanzania, where there's an absence of vegetation that's present? Is that, in your mind, where an artificial fertilizer or some other artificial method of delivering those minerals to account for the lack of micronutrients or the lack of microorganisms because there is no vegetation? What's the first step in that sort of barren wasteland?
I'm not sure I'm not the expert. So I know that what some people have done in some areas, like There are some people in Nevada who have used degraded, empty land that mining degraded. And what they did was they started, they covered the land with hay and brought in cattle. So that was the first thing that they did, was they brought in cattle, and they brought in this hay and brought in this cattle, and the cattle do their thing of stomping that into the ground and pooping on it and peeing on it and getting, cows are full of microbes. Cows are just like a microbe factory, microbe tank, people call them, and leaving that on the soil. And then they would come in after a lot of plant life that would have been, seeds can stay alive in the soil for an awful long time. A lot of the native vegetation that wasn't coming up there did start to come up in that area. But I think there are many ways to attack that, of getting some organic material onto the soil, into the soil, whether it's through plants. And I don't know. I think in some cases somebody, if they wanted to jumpstart it and there was no other way, it's possible they would use chemical fertilizers. But I think that, from the scientists that I have talked to and that I respect a lot, chemical fertilizer does interrupt that feeding relationship between plants and soil microorganisms, that plants kind of get lazy. If plants don't have to share that carbon fuel with microorganisms to get some of their major nutrients, then they just won't. And so it depletes that population of microorganisms in the soil, and that has all these other ramifications. So I think that probably where people are trying to take this approach to those really damaged, empty lands like that, they are trying to do it without the chemical fertilizers.
Hi, Chris.
Hi.
Hi. My question's about seeds. So the other day I heard a discussion about Monsanto trying to purchase Synergy, which means that the company, if they merge, would own 1/3 of the seeds and the pesticides. And we're talking about GMOs, and we're talking about not having choice for the farmers. So I guess my question is about seeds and what your feeling is about some of these farmers not having choice anymore, or might not have the choice about purchasing the seeds, and maybe the lack of organic or choice in seeds, and what that does really to the environment and the soil.
Well, that's a really big question. Yeah, GMOs. I think the whole debate about GMOs has gotten, it is such a complicated question and debate. And I loathe them. And it's not because I worry about their impact on human health. I think that that's quite conceivably a valid worry. I just haven't seen anything that completely convinces me of that. But I think the problem with GMOs is that they were designed and they are created to facilitate industrial agriculture. They are part and parcel of that system. And every time I hear an argument that they are needed to feed the world, that coming from Monsanto and some of those big seed companies, that's what's needed to feed the world, I think, Exxon doesn't get away with saying, well, we need to drill some more because, poor mothers in Cleveland need to read to their children at night. They don't get away with that argument, and somehow everybody, or a lot of people, buy it when it comes from these big seed companies, that we're doing this to feed the world, not because we're doing it. It's a great business plan. I think that it's really a big problem with GMOs. They do, it's not just that it's GMOs. It's just that there has been tremendous concentration in the seed industry, and there are many crops, many seeds that worked well for farmers for generations, that when some of these bigger players buy the companies that have the rights to those seeds, they close down those seed lines. So lots and lots of very good seeds that have been standbys for farmers forever, they can't get anymore because the rights are owned by Monsanto or one of the other big companies, and they can't use those seeds anymore. So they kind of have no other choice many times but to go for the GMO seed. Even Gabe Brown, my rock star farmer, there are a couple of years when he didn't get to the store, he didn't get to the kiosk. What do they call it? It's not the store. No. Anyway, didn't get to the place where he buys seed. He didn't get there quick enough to buy the non-GMO seed. That was all he had to plant that year was GMO seed, because it's very, very hard to get to get their hands on that. So I think that's a huge issue. I think it's a huge issue for food justice worldwide. I think it's a huge issue. And just the whole GMO seeds. Those seed companies talk a lot about all the possibilities that GMO seeds can offer the world, with whatever, seeds plants that'll grow this way, then avoid this problem they've always had. But the fact is that, let me see if I can remember the numbers right, it's something like 85% of all GMO seeds are engineered to resist Roundup. I mean, it's a business plan. It's not it's not something to save the world.
My name is Zoe Mueller, and I spent a considerable amount of my time thinking about and working on vacant land reuse here in Cleveland. And it seems to me that we are positioned in a way to restore a lot of soil health by the way that we handle our demolitions and what we do following that. And so I'm wondering if there are any farmers or practitioners or researchers that you've encountered that have really spent a lot of time thinking about how you build from it's not ground zero, but all of that soil is tremendously disrupted when the demolition happens, and then we are introducing, in most cases, foreign or new material to fill in what is no longer there.
Mm-hmm.
So I'm wondering sort of thoughts on that.
Well, I think it's a great thing that you're doing it. I don't know anybody who's specifically making a study of that, but it's actually that's what these people in Seattle were doing in this book that I'm reading, which isn't out yet, but it will be soon. They are taking a piece of land that had really degraded soil and turning it around. But I think that there are tools that are being used in agriculture that will apply to that. Of mulching and composting and cover cropping, all those things are going to work in any scenario. But maybe you should write a book on that.
Hi, I'm Callie. I'm a research intern at Holden Arboretum. When you were talking about the infrastructure that's in for the whole agriculture business, I think a lot of us are depressed because we don't know how to tackle that. What you're talking about, it sounds great, and it could really save us and to save the soil and whatnot, but we're scared. We don't know how to tackle the big companies or whatever social infrastructure that's there, and we don't know how do we change that to fit this new model, or do we just take it all down because there's political things and jobs and lots of money involved, and we don't. How do you know possibly where anybody could start? Really just taking all that down.
Well, you already are. I mean, you already are starting. One of the things that I wrote about in my book was how ranchers in New Mexico and in the Southwest started to change when foodies, which is, speaking of blurbs, when I was trying to get blurbs for my book, I asked Deborah Madison to do one, and she said, "Why do you have to use the word foodies? That's a derogatory term." And I thought, well, I just can't come up. I don't know what else to use. It's like one word and it works. But how ranchers in that part of the country, when they first heard that some picky pain-in-the-ass consumers were wanting grass-fed beef and they didn't want feedlot beef anymore, that they were just like, no way, I'm not going to go back to the way my grandfather did it. And, no way, that's not even possible. It doesn't pencil out, blah, blah, blah. And how over a 5 or 6 year period that really started to change. All these guys who said, I'm not going to do that, I can't do that, they did that. They started to change in response to consumers. So I think that I was thinking about this on the way down, about the food movement, and how the food movement has seemed to some people to be such a frivolous thing, it's something that just like this elite of us, we want better food. Well, we want better land, period. And we want better food for everybody, period. And more people, I think, are getting pulled into that. And I don't even know if we should call it a food movement, but more and more people are being pulled into that movement. What I find very exciting is that, I'll go and talk at places, and there are chefs, and there are farmers, and there are environmentalists, and there are, neighborhood groups of families who are concerned about the food their kids eat. There are all these people sort of coming together around the issue of how we impact the land through agriculture, and things are starting to change. The Secretary of Agriculture just gave a big speech a couple of weeks ago where he talked about carbon sequestration in the soil. Now, that's bound to terrify a lot of the big ag companies because they can talk a little bit about how they're all part of that program, but honestly, their products don't support that. So I do see things really changing. When I wrote my book, I did not know. Did I even know that they existed? I knew that the Soil Conservation Service, which came out of the Dust Bowl days, I knew that they existed someplace. I think I knew that they had become the Natural Resources Conservation Service. That's their modern day. But I didn't know until my book had been out for about a month, and I got a call from somebody who works for the NRCS that soil health is now like their biggest passion, and that they have the, they go around the country working with farmers, trying to get them to change really harmful soil biology killing processes into very positive soil enhancing processes. And that's really exciting work. So I think it is changing, and I think we are changing it. And we certainly have a lot, a ways to go, and there are very powerful interests who stand against it. But I think especially as the connection between what we do to the land through agriculture and what's happening to our world and our climate and our oceans in general becomes clearer and clearer. And even though there isn't enough research money flowing into that, it is coming out. I think more and more people will figure out ways to pressure the system to change.
That was cute.
That was the cue for the last question or one more?
That was the cue for the last.
Okay. Thank you.
I can't resist. I'm supposed to read this script, but to that final question, we are not responsible for feeding 9 billion people in the world. We're responsible for feeding ourselves. So if you focus on that, it's much less of a daunting task, and you can start to take direct action to impact your diet and your community's diet around you. It's a little bit more easy to change. So today at the City Club, we have been enjoying a Friday forum featuring Kristin Ohlson, author of The Soil Will Save Us. Thank you, Mrs. Ohlson. Thank you, ladies and gentlemen. This forum is now adjourned.